Greetings to all the viewers. Now we are going to continue with the session called Alpha Terpeniol. This is the part of terpenoid taken from the textbook of natural products, Nurturing Livelihood. Alpha terpeniol is a kind of material which is naturally occurring monoterpene. Monoterpene means for if two isoprene units got combined so that it is called monoterpene. Moreover, hydroxy functional group is also allocated for this alpha terpeniol. In that only it is manifested with ol indicated for hydroxyl group. So that C10H18O is the molecular formula for the given compound. So whatever series of sessions we conducted earlier, all are available at the channel called World of Competitive Chemistry. Let me continue with this alpha terpeniol. Molecular formula will be C10H18O, widely found in essential oils. Being terpenoids are kind of essential volatile oils, so that here alpha terpeniol is a kind of material essential oil. It is a cyclic terpene alcohol derived from paramethane skeleton. Paramethane skeleton is a fundamental one from which you can derive this alpha terpeniol. IUPAC nomenclature is allocated. IUPAC means for International Union for Pure and Applied Chemistry. 2,4-methyl cyclohexane 3-ene 1-yle propane 2-ol is the IUPAC name for the given compound. Let me repeat. 2,4-methyl cyclohexane 3-ene 1-yle propane 2-ol is the name IUPAC name for alpha terpeniol. Occurrence found in oils like pine oil, eucalyptus oil, petit grain, and kaju put. So these many kind of plant origins are able to give that alpha terpeniol, which is the essential oil. Everybody aware about the pine trees, which are mostly present at the mountain regions. Eucalyptus is the kind of plant which is medicinally important one, from which eucalyptus oil will be extracted. Here petit grain trees are also you can find alpha terpeniol from these petit grain trees, and kajaput trees you can observe that kajaput tree over there, so from which also you are able to extract this alpha terpeniol in the maximum extent. If you want to know about the chemical skeleton composition of that alpha terpeniol, here is the cyclohexene ring system where methyl substitution is located on this carbon, and this fourth carbon is linked with this carbon chain with CH3 COH CH3. So this is the way a kind of molecule alpha terpeniol is given. This is a cyclic terpenoid molecule. Exists in optically active form. If you want to know about that orientation of this compound, here you can find the chirality, chiral carbon. Always chiral carbon is nothing but any carbon is which is surrounded with 4 different functional groups, which is indicated with a star mark. And here is another carbon atom. You can find the chiral. So both the chiral carbons mean for their what optical isomerism. Optical isomers are manifested over there. Alpha terpeniol will be there. Beta terpeniol, where hydroxyl group is completely shifted to the top region, and that double bond is moving over there, which is beta terpeniol. And this double bond is also shifted to another carbon atom, so that here terminal double bond shifted to internal one, and this is called gamma terpeniol. And here is the again shifting of double bond to the top edge carbon atom, so that here exocyclic double bond, and here is the hydroxyl called delta terpeniol, and there is a location of hydroxyl at the ring carbon atom, and here is the olefinic double bond. This is called 4-terpeniol. These many kind of possibilities are given for optically active isomers, so that alpha, beta, gamma, delta, and 4-terpeniol are present. Moreover, alpha terpeniol is naturally available, abundant material with a high perspective of applications in the medicinal field, right? Significance. Let me introduce the significance or application point of view this alpha terpeniol. Important intermediate in the terpenoid chemistry. Terpenoids mean for polyisoprene units. In this, it is the kind of intermediate. From this alpha terpeniol, you are able to generate various types of terpenoid moieties. analog compounds will be synthesized so that it is the key intermediate in between. So generally it is the essential oil, right? Oily materials having perfumery tendency and fragrance is the important feature for this alpha terpineol, so that perfume and fragrance industry you can utilize this compound. Biologically antimicrobial as well, not only perfumery but also medicinal, right? Antimicrobial mean for any pathogens causing diseases like bacteria, virus, algae, fungi, protozoans, any kind of tiny organisms which causing diseases can be destroyed by means of alpha terpineol. Anti-inflammatory, any inflammations like a swelling with a severe pain, and that conditions also uh, mitigated by means of alpha terpineol. Acts as a precursor in the synthesis of other terpenoids. Other terpenoids can be easily synthesized starting from this alpha terpineol. Alpha terpineol perfume ingredient, you already aware about this one, and whose structure is manifested with the cyclohexene methyl substitution at one of the carbon, and here isopropyl substitution with the hydroxyl functionality over there. This is the entire compound composition, and you can find the perfumery activity over there. Lavender flowers are manifested over there, and this is the kind of alpha terpineol, right? How can we extract? Being it is the natural product, we need to know about how can we extract this compound in the larger percentage of purity. Alpha terpineol is obtained mainly from the natural essential oils, right? Alpha terpineol mainly extracted from natural essential oils. Steam distillation is the most suitable method for the extraction process. Pine oil can be taken and subjected to steam distillation. Based on their boiling point, different fractions will be separated. Fractional distillation will be there, so that isolation of alpha terpineol, so that terpineol rich fraction will be segregated by means of this fractional distillation process. Steam distillation, fractional distillation, both are applied over this alpha terpineol extraction process. Purification simply taken by vacuum distillation. Vacuum distillation means for distillation taking place in the absence of atmosphere is said to be vacuum distillation, and recrystallization giving high quality of the final product. So the solid will be purified further extent, so that high grade final crystalline solid of that alpha terpineol will be originated. So this is the way extraction process will be accomplished. Let me give the detailed documentation regarding this isolation of alpha terpineol, isolation of essential oil from the plant part to be taken. So the plant having essential oils are generally highest concentration in the particular time. So better yield essential oil plant material have collected in the particular time. Expression method, steam distillation, extraction, volatile solvents, adsorption, purified fats. These many type of extraction methods you can choose either of the method, not all the methods suitable. Rather, based on our availability of components, availability of the infrastructure, you may choose either of the method for this isolation or else extraction of alpha terpineol. Let me repeat once again: expression method, steam distillation, extraction by means of volatile solvents, adsorption in the purified fats. Either of the method you can apt in order to achieve the final product. Steam distillation is most widely used method. Though these many methods are there, steam distillation is commonly applied for this extraction process, right? Schematic representation is provided. Let me introduce in detail. So isolation of alpha terpineol. First of all, let me take the leaves, dry leaves of that plant origin, any kind of plant you may take. Here these many plants are mentioned. You simply take the pine trees. Pine tree leaves collected, for example, let me assume pine tree leaves were taken over there, and they further introduced into these leaves, washed, dried, and powdered. Initially powdered leaves, that powdered leaves of pine tree are subjected to steam distillation process. Steam distillation mean for we have to take that compound, that powdery compound of these leaves, pine leaves, to be added with a kind of suitable solvent first. Later, you need to rise the temperature at the bottom with the Bunsen flame. Whenever temperature rises, here the water condenser is fitted with in order to avoid the volatile vapors. So if the molecule is totally vaporized, no, nothing will remain in that, only solvent will remain in that. In order to avoid that kind of loss of compound, during the distillation process, we need to circulate the water. Water circulation able to condense the vapors and again get back the entire material without any loss. High percentage of yield you can achieve by means of this water circulation. Condenser equipped with the water circulation is the mandatory thing you need to perform, right? So safety tube is also indicated over there, and that is connected with the inner chamber where steam distillating chamber will be there. Again, heating is required over there. From the first container, that mixture will be entered into second container later on. Later on, again, here we are having a kind of condenser which is circulated with the distilled water, and that water inlet and outlet will be there. So that continuous water circulation able to avoid the evaporation of that particular compound alpha terpeniol. Finally, you can collect the kind of fractions into this conical flask or else volumetric flask, where distinctive layers you can notice. One is the organic layer, one is the aqueous layer. You can notice essential oil will be simply collected because water and oil layers are immiscible. Both are distinctive layers, so that it is very convenient to separate by means of separating funnel. Liquid-liquid separation is the common thing. If both are immiscible, simply, so that essential oil will be collected later on. You need to apply the pressure. Whenever pressure is applied, what happens? That entire compound is compressed. So alpha terpeniol is collected in this tank that is indicated over there in the small quantity, small volume. This is the way entire process of extraction is given in the schematic representation. Hopefully, it is really informative. Really, you can understand what is happening during the extraction process. Leaves were taken and finely grounded, mixed with solvent and heated to high temperature so that steam will be generated and water circulation able to condense the vapors of this compound and another container. It entered into later, again heating, continuous heating is required so that mixture of compounds, water layer and organic layer are running together through the water circulating a flask. So this is the way you need to collect into a final outlet where organic and aqueous layers together mixed over there, and that simply separated by separating funnel. Essential oil collected and reduced pressure applied. Alpha terpeniol is collected in high quality or high purity. So this is the way extraction process is applied. Later on, alternative source of alpha terpene, alpha pinene hydration, right? Alpha pinene hydration is another methodology for this alpha terpeniol, where you can take alpha pinene. This is another terpene compound only. Supposed to be protonated. Whenever protonation taking place, being double bond is unsaturated, when one of the carbon is protonated, another carbon obviously experiencing positive charge over their carbocation. In order to satisfy this carbocation, what is happening? This bond will be cleaved, being a bicyclic ring system. This is a small four-membered ring, highly sterically strained, right? In the perspective of stereochemistry, it is a highly strained ring system. So that ring opening is the common phenomenon taking place. Whenever ring opening taking place, it is becoming bicyclic, is becoming monocyclic with a six-membered ring. That is highly convenient, sterically less hindered one. And wherever a ring opening taking place, that carbon experiencing that loss of electrons indicated with a positive sign. And whenever bond is moving towards that side, here the double bond origination you can observe. Further hydration. So water will be added so that cationic carbon will be added with this water molecule, so that here hydronium ion formation is possible. Deprotonation taking place. Finally, you can achieve alpha terpeniol as the final product. This is the alpha pinene. Alpha pinene is the starting material and alpha terpeniol is the final product. So this is also possible to biotransform that alpha pinene into alpha terpeniol. Structural elucidation, this is the most important thing actually. Structural elucidation of alpha terpeniol is the most important one. Not only alpha terpeniol, any of the natural product, because we are extracting the compound from the nature. We need to understand what structure it is actually possessing. Then only you can understand what kind of biological activity it able to exhibit. That is the reason why structure activity relationship are directly correlated, right? That's the reason why alpha terpineol structural elucidation we are going to perform. First of all, molecular formula. So, simply molecular formula you can achieve by means of elemental analysis procedure. So, it is accorded that C10H18O is the molecular formula for the compound. It indicated first 10 carbons simply indicates monoterpene. Two isoprene units got combined. Simple isoprene unit is manifested with 5 carbon atoms. If two are combining, 10 carbons is the common skeleton. And that is the reason why C10H18O. This is given from elemental analysis process. Later on saturation. Whether the compound is saturated, unsaturated, we don't know because we directly extracted as a crude product from the pine tree. For example, after extracting that one, we need to know whether the double bond presence is there or not. In order to understand the presence of double bond, this alpha terpineol compound was simply taken into the two test tubes. One of the test tube added with bromine water, another test tube added with platinum and hydrogen gas. Sorry, hydrogen and platinum gas. This is the way a kind of bromination and hydrogenation both are susceptible for the indication of presence of unsaturated, presence of double bond or triple bond. It indicated that bromination giving rise to C10H18OBr2, hydrogenation giving rise to C10H20. 18 converted into 20 means two hydrogens got added and O remains as such. Simply you can understand here two bromines when added, one double bond presence, one double bond able to add one side of bromine to the carbon, and either side bromine to the second carbon. This is the way. Addition of 1 mole of bromine indicates presence of one double bond. Again, addition of 1 mole of hydrogen indicates again one double bond present in the molecule. This is the reason why the compound is said to be unsaturated because it gave the positive test with the bromine water and the hydrogen in the presence of platinum metal. That is the reason why unsaturated, and moreover, one double bond is present because it is stoichiometrically added with 1 mole of bromine and stoichiometrically added with 1 mole of hydrogen as well. This is the indication for unsaturation. Let me go for the functional group test. Tertiary alcohol presence is positive. Tertiary alcohol is present, you can understand. So that is understood by tertiary alcohol compound is understood by Lucas test. Ester formation is also possible, conforms the hydroxyl group. So it able to generate the ester. Whenever this alpha terpineol unknown compound was taken, whose structure is not known to you, that is added with known carboxylic acid. After the addition of carboxylic acid and light heating, you can experience the fruity smell within. That indicates ester got generated within the test tube. So here, whenever carboxylic acid added to unknown compound, ester formed. Only the required ingredient will be hydroxyl, right? That is the reason why alpha terpineol is hydroxyl containing compound. This is the confirmation for the functional group, identification for the functional group. So position of tertiary alcohol was found by oxidation process. Where is that alcohol is there? That we need to trace out. We need to isolate that position of OH group by means of the process called oxidation. In order to get that one, first of all, let me go with alpha terpineol C10H18O. Now you can add 1% alkaline caminophore solution, potassium permanganate to be added, that able to generate hydroxylation. Wherever double bond is present, that is hydroxylated. Hydroxylation means for OH added at the double bond carbon atom. Already one of the hydroxyl is there. That understood by this ester formation. And more two hydroxyl generated, so that totally it is becoming trihydroxy compound, and the molecular weight is also raised accordingly. And later, you need to add this chromic acid in the presence of acidified condition, that is acetic acid, oxidation simply taken. Ketohydroxy acid intermediate will be generated. Ketohydroxy acid intermediate. We need to remove the water so that lactonization. So here hydroxyl group got combined together by the removal of water molecule lactonization taking place. Ketolactone will be generated, that is C10H16O3. So lactone form. Lactone means a cyclic ester within the ring system. Alkaline camphor, again one more mole will be added while boiling process. So whenever boiling is accomplished, wherever ketonic functionality is that totally discarded. So two carbons when removed, from the C10 carbons, you can achieve only C8 carbon atoms. Means two carbons discarded from that. That is called a terpenoylic acid. Terpenoylic acid is the another intermediate generated over there. Alkaline camphor, again one more mole will be added. Terabic acid and carbon dioxide originated. Carbon dioxide removed means one of the carbon lost. That's the reason why C8 turned into C7. So C7 carbon formation is possible. This is the way you can locate the position of that alcoholic functional group. Right? Mild oxidation, there is a formation of ketone is possible. Strong oxidation, cleavage giving rise to final product. Ring structure is possible. Right? So this is the entire procedure. Whatever we discussed, that is repeated once again. So this is the reason why oxidation studies will be carried. So this is the compound structure D of hemoterpenyl methyl ketone. Terabic acid structure is provided for the better understanding. Cyclic lactone is indicated over there. COH will be there. Terabic acid means this is the terabic acid C7 carbons with a loss of CO2 moiety. So here how the CO2 moiety will be removed. Here is the cleavage you can. Terpenoylic acid intermediate. Here you can notice terpenoylic acid, right? Terpenoylic acid will be removed with one of the carbons so that here terabic acid will be formed. So here is the terabic acid, 7 carbons. One of the COOH removed by this alkaline camphor warm conditions so that here decarboxylation. So this is terpenoylic acid. Whenever we are taking compound number D, ketolactone it will be, that ketolactone is also indicated for better understanding. So these are the kind of oxidation patterns for this alpha terpineol compound. Dehydration process. Dehydration means for removal of water molecules, C10H18O, whenever treated, slightly heated, not treated, slightly heated to higher temperature, it is able to remove the water molecule, giving rise to C10H16. So oxygen removed in the form of water molecule, so that here this is the dehydrated product. C10H16 will be generated, which is the cyclic product. The cyclic product will be originated. Reaction with sulfuric acid. Whenever C10H18O, this is called what, alpha terpineol, treated with concentrated sulfuric acid. Concentrated sulfuric acid again able to remove the water molecule and internal cyclization taking place. Benzene ring with one side methyl and the other side isopropyl. This is called paracymene. Paracymene is a key intermediate for the synthesis of all kind of terpenoids. So paracymene, from the paracymene you can synthesize all kind of terpenoids. That's the reason why it is the key intermediate. So that can be clearly achieved starting from this alpha terpineol by treating with a strong acid, sulfuric acid. So dehydration giving rise to paracymene. Right. Structure contains cyclohexane. This is the known compound, right? Known compound indicated that, known compound formation indicated that there is a cyclic ring. The compound is accompanied by the cyclic ring system. And already we know tertiary alcoholic group is also there upon this molecule. And the isopropyl substitution is also there. Being it is the kind of isopropyl side chain within the paracymene only. Paracymene skeleton is required, right? So that here paracymene, isopropyl group is also the compulsory condition. From this paracymene formation, these many inferences drawn. It indicated that there is a cyclohexane ring. It indicated that there is an alcoholic group in the molecule. There is isopropyl substitution within. So you got the entire structural idea about this alpha terpineol by the formation of this paracymene. It is the key reaction within the structural elucidation of alpha terpineol. Paramethane framework is located within. Paramethane means for the cyclohexane with methyl and isopropyl. If this is the skeleton, that is called paramethane. This skeleton is allocated for this alpha terpineol. here alpha terpeniol, if treated with water molecule, water if added, double bond is added with the water, hydration taking place at the olefinic double bond, so that one more hydroxyl group is introduced upon this bridgehead carbon, which is called terpene. Oxalic acid, if treated with this one, oxalic acid is able to remove the water from this carbon, so that here is the double bond formation taking place. Concentrated sulfuric acid, known paracymene will be originated. Potassium bisulfate dehydration taking place, that generates the terminal double bond, which is called a limonene. This many kind of known products generated by suitable reagents treated upon this same compound called alpha terpeniol. All are known isolated compounds only. From this, you can draw that it is the cyclic compound, it is the tertiary hydroxy, it is the isopropyl ring, it is the double bonded carbon atom, moreover double bond in between these two carbons only, then only hydroxyl will come at this position. And a methyl substitution is also present. So this will give the confirmation for the entire structure of alpha terpeniol. So a pure sample of alpha terpeniol was isolated in the year 1885 by the scientist Otto Bullock and analyzed it for C10H18O. A single oxygen atom alpha terpeniol is therefore present in the alcohol function. Oxygen corresponds to hydroxyl only. Alpha terpeniol has high single stereogenic center. Natural alpha terpeniol is dextrorotatory. Further structure elucidation alpha terpeniol rested on the stepwise degradation trihydroxy compound. So by this we are going to conclude. So the structure of the alpha terpeniol that is indicated over there. Cyclohexene with methyl substitution at the carbon number 1, isopropyl substitution at the carbon number 4, and hydroxyl at this tertiary carbonate. So by this, we are going to conclude the session. Hopefully it is informative for your preparation, either conceptual understanding or else competitive exam point of view. This session is really informative. If you are seriously preparing about the chemistry content, you can best choose the channel called World of Competitive Chemistry. Vast information you can retrieve from this channel. Thank you very much for your patient listening.